Hello there, and welcome to the Science for Sleep channel. Tonight we'll explore the cosmos, a universe that has been quietly expanding for 13.8 billion years. Ancient stars forged the atoms in your body, black holes sit in silence at the heart of galaxies, and light from worlds long gone is still traveling through the dark to reach your eyes tonight. These vast, unhurried wonders have existed long before this world, and they will continue long after. You've got nothing to do but rest. Let your mind grow soft, your breathing slow, and your body grow still. If this helps you sleep, consider liking and subscribing. One sleepy soul at a time. Now let's begin with the cosmos. There are more stars in the universe than grains of sand on all the beaches on Earth combined. If you tried to count them one by one, it would take longer than the universe has existed. Scientists estimate there are around 200 billion trillion stars out there, each one a sun in its own right. Some are smaller and dimmer than ours, and some are so large that our entire solar system would fit inside them. Every single one of those stars burns with its own light, quietly, somewhere in the dark. The Milky Way is on a slow collision course with a neighboring galaxy called Andromeda. Right now, Andromeda is moving toward us at about 110 kilometers every single second. In about 4 billion years, the two galaxies will begin to merge, their stars weaving together like two clouds passing through each other. The night sky on Earth, if anyone were still here to see it, would be filled with rivers of new stars. It would be the most beautiful thing the universe has ever shown this world. A black hole has gravity so strong that nothing, not even light, can escape it once it gets too close. If you could fall into one, you would be stretched like a thread of cosmic spaghetti long before you reached the center. Scientists once thought black holes were purely theoretical, but today we have actual images of them taken by telescopes working together across the planet. At the center of our own Milky Way, there is a supermassive black hole called Sagittarius A, quietly waiting in the dark. It is 4 million times heavier than our sun. The universe is about 13.8 billion years old. That number is so large that it has almost no meaning to our minds. To put it gently, if the entire history of the universe were compressed into one single year, all of human history would fit into the last few seconds of December 31st. Everything we have ever built, written, loved, or dreamed happened in the blink of a cosmic eye. The universe was ancient long before our planet even existed. When you look up at the stars at night, many of them are already gone. The light you are seeing left those stars thousands or even millions of years ago, traveling across empty space until it finally reached your eyes tonight. Some of those stars burned out long before life appeared on Earth. You are not seeing the sky as it is right now. You are seeing the sky as it was, like a quiet memory the universe left behind just for you. The Milky Way has a supermassive black hole sitting at its very center, called Sagittarius A. It is surrounded by a dense cluster of stars that orbit it at incredible speeds, completing full orbits in just a few years. For most of the galaxy's life, this black hole has been relatively quiet, not consuming much material. Scientists watch it carefully with radio telescopes, listening for signs of activity deep in the heart of our galaxy. It sits there in silence. 4 million solar masses of pure gravity, patient and still. There are at least 2 trillion galaxies in the observable universe. That is the number 2 followed by 12 zeros. Each of those galaxies contains hundreds of billions of stars, and most of those stars likely have planets orbiting around them. The observable universe is just the part we can see from Earth, everything within reach of our light. Beyond that boundary, the universe keeps going in ways we may never be able to measure or imagine, stretching on in every direction without a visible end. Our entire solar system, the Sun, all 8 planets, every moon, every comet and asteroid, is just one tiny speck inside a single spiral arm of the Milky Way. We are not even close to the center. We live in a quiet, outer region of the galaxy, far from the bright and crowded core. From above, our solar system would be invisible without magnification, a grain of dust on the surface of a continent. Everything we have ever known exists in that single, unremarkable, perfectly beautiful spot. The universe is not only expanding, it is expanding faster and faster with every passing moment. Something called dark energy is pushing everything apart, like invisible springs hidden inside the fabric of space itself. Galaxies that are close to us now will one day be so far away that their light will never reach us again. In the very distant future, the night sky will be nearly empty as galaxies drift beyond our horizon forever. For now, they are still there, still visible, still close enough to see. Stars are born inside enormous clouds of gas and dust called nebulae. These clouds drift quietly through the galaxy for millions of years until gravity begins to pull parts of them together. Slowly, the material at the center grows denser and hotter until one day it ignites and a new star begins to shine. The leftover gas and dust swirling around it often forms planets over time. Every star you have ever seen, including our own sun, began its life as a quiet, cold cloud drifting through the dark. When two galaxies collide, their stars almost never actually crash into each other. Galaxies are so enormous and their stars so spread apart that the space between them is almost unimaginably vast. When the Milky Way and Andromeda finally meet, most stars will simply drift past one another like two swarms of fireflies passing in the night. The galaxies will merge, their shapes will change, and new stars will be born from the gas clouds that collide and compress. It will be violent and beautiful, and almost nothing will actually touch. The Milky Way is slowly pulling smaller galaxies toward it and absorbing them right now as you read this. Several dwarf galaxies orbit our own, gradually being stretched apart by the Milky Way's gravity. Their stars are being scattered into long streams that wrap around the galaxy like soft ribbons of ancient light. This process has been happening for billions of years, and the Milky Way has grown larger with every galaxy it has quietly consumed. Our galaxy is, in the gentlest way, a patient predator. About 85% of the Milky Way's mass is made of something we cannot see, touch, or detect directly. Scientists call it dark matter, and they know it exists only because of the gravitational effect it has on the stars and gas around it. Without dark matter, the outer edges of our galaxy would spin too fast and fly apart into space. It holds the whole structure together like an invisible scaffolding wrapped around everything we can see. We do not know what it is, and that mystery has been sitting quietly in the sky for decades. Light from our sun takes about 8 minutes to travel from the surface of the sun to the surface of the Earth. That means when you feel sunlight on your skin, you are feeling energy that left the sun 8 minutes ago. But light from the nearest star beyond our sun, a small red star called Proxima Centauri, takes over 4 years to reach us. The stars you see tonight are not neighbors. They are distant, separated by distances so large that even light needs years, centuries, or millennia to cross them. Speed itself slows down in the face of cosmic distance. Our sun is quietly aging, and one day, in about 5 billion years, it will begin to run out of fuel. When that happens, it will slowly expand into a red giant, growing so large that it will swallow Mercury, Venus, and very likely the Earth itself. The oceans will evaporate, the atmosphere will be stripped away, and the surface of our world will melt back into the star that created it. After that, the sun will shed its outer layers and leave behind a small, dense, cooling ember called a white dwarf. Everything we are will return to the cosmos. The universe is not a random scattering of galaxies floating in empty space. Instead, galaxies are arranged along enormous invisible structures called the cosmic web, long filaments and sheets of matter that stretch across hundreds of millions of light years. Where these filaments cross, great clusters of galaxies gather together. The spaces in between, called voids, are nearly empty and can be hundreds of millions of light years across. When scientists map the large-scale universe, it looks remarkably like the structure of a human brain or the web of a spider, seen from very far away. Above and below the flat disk of the Milky Way, there are two enormous bubbles of energy stretching out into space, each one about 25,000 light-years tall. Scientists call them the Fermi bubbles, and they were likely created by a massive outburst of energy from the black hole at the center of our galaxy millions of years ago. They are invisible to the human eye, but glow with high-energy radiation when seen by special telescopes. They hang above and below our galaxy like two enormous silent balloons. We live inside a galaxy that has already experienced explosions we can barely comprehend. Some of the oldest stars in the Milky Way are found in the halo, a wide spherical region that surrounds the flat disk of the galaxy. These stars are ancient, some nearly as old as the universe itself, formed before the galaxy had even taken its current shape. They orbit the center in long, looping paths, unlike the more orderly orbits of stars in the disk. Scientists study them as fossils, reading their chemistry to understand what the universe was like in its very earliest days. They are the elders of the cosmos, burning quietly in the outer dark. The part of the universe we can actually observe is about 93 billion light-years wide, and it contains everything we will ever be able to see with any telescope, no matter how powerful. But the total universe, the part beyond what light has had time to reach us from, is almost certainly much, much larger, possibly infinite. There is a boundary around us not made of walls, but made of time. Light from beyond that boundary simply has not had enough time to reach us since the Big Bang. We are living inside a bubble of visibility, surrounded by a universe we may never fully see. Every single atom in your body was made inside a star. The calcium in your bones, the iron in your blood, the oxygen in every breath you take. All of it was forged in the nuclear furnaces of stars that lived and died billions of years ago. When those stars exploded in massive supernovas, they scattered their material across space. That material drifted through the galaxy for millions of years, before slowly gathering into the cloud that became our sun, our Earth, and eventually us. You are not just looking at the stars tonight. You are the stars, resting. The Milky Way takes about 230 million years to complete just one full rotation around its own center. This vast, slow turning is called a cosmic year, or a galactic year. The last time our solar system was in the same position in the galaxy that it occupies tonight, dinosaurs had not yet appeared on Earth. Since the sun was born, it has completed only about 20 of these enormous rotations. The galaxy turns so slowly that no human civilization, no matter how long it lasts, will ever notice it move. A teaspoon of material from a neutron star would weigh about 1 billion tons on Earth. Neutron stars are the collapsed remains of massive stars that exploded in supernovas, and they pack an almost unimaginable amount of matter into a sphere only about 20 kilometers across. A single one of these stars contains more mass than our entire sun, squeezed into something smaller than a city. The gravity on their surface is so intense that a marshmallow falling onto one would hit with the energy of an atomic bomb. They are among the most extreme objects the universe has ever created. For hundreds of millions of years after the Big Bang, the universe was completely dark. There were no stars, no galaxies, no light of any kind. Just vast clouds of hydrogen and helium drifting slowly through the dark. Scientists call this period the Cosmic Dark Ages, a long, quiet chapter in the universe's story before anything had learned to shine. Then, slowly, gravity began to pull those clouds together, and the first stars ignited one by one, like candles being lit across an enormous room. The universe saw light for the first time, and it has been glowing ever since. When you look up at the night sky on a clear night, you are not seeing the universe as it is right now. The light from the stars nearest to us left those stars years ago. The light from stars in distant galaxies left millions or even billions of years ago. In a very real sense, the night sky is a collection of different moments in time, all arriving at your eyes at once. Looking up is looking back, and every star is a quiet message from the past, still traveling toward you after an unimaginable journey. The universe has no single center. After the Big Bang, space itself expanded in every direction equally, and every point in the universe sees every other point moving away from it. If you were standing in a galaxy billions of light years from here, you would see our galaxy drifting away from you, just as we see distant galaxies drifting away from us. There is no special place, no middle, no edge we can point to and say the universe begins here. Everything is the center, and everything is the edge, all at the same time. The Milky Way contains somewhere between 100 billion and 400 billion stars, and scientists are still not entirely certain of the exact number. The difficulty is that the galaxy is full of gas and dust that blocks our view of large portions of it, especially toward the dense and crowded center. We are mapping our own home from the inside, which is a bit like trying to draw a map of a city while standing in the middle of it on a foggy day. Every year, new telescopes help us see a little further, count a little more accurately, and understand a little better the enormous place we call home. Stars do not all orbit the center of the Milky Way at the same speed. You might expect stars farther from the center to move more slowly, the way outer planets in our solar system orbit the sun, more slowly than inner ones. But in the Milky Way, stars far from the center move almost as fast as those closer in. This strange behavior puzzled scientists for decades until they realized that invisible dark matter spread throughout and beyond the galaxy was adding extra gravitational pull and keeping the outer stars moving quickly. It was one of the first strong clues that most of the universe is made of something we cannot see. The Milky Way is surrounded by a group of smaller galaxies that orbit it, like moons orbit a planet. The two most famous are the Large and Small Magellanic Clouds, which are visible from the southern hemisphere as faint, glowing patches in the night sky. They are being slowly pulled apart by the Milky Way's gravity, leaving trails of stars and gas behind them as they orbit. One day, billions of years from now, they too will be absorbed entirely into our galaxy. For now, they travel alongside us through space, quiet companions on a very long journey. Every second, somewhere in the universe, a star is exploding in a supernova. These colossal explosions are so bright that a single one can outshine its entire host galaxy for days or even weeks, releasing more energy in that short time than our sun will release in its entire lifetime. Supernovas are not just endings, they are also beginnings. The tremendous force of the explosion scatters newly forged elements across space, seeding the surrounding gas clouds with the raw materials for future stars, planets, and perhaps life. Every explosion is also a seed. Our sun is a perfectly ordinary, medium-sized yellow star, and yet it is more massive than 99.8% of everything in our solar system combined. It is so large that about 1 million Earths could fit inside it, and yet, by the standards of the galaxy, it is unremarkable. There are stars hundreds of times larger, thousands of times brighter, burning with a fury that makes our sun look like a single candle. The universe is full of suns, each one warming its own small corner of space, each one the center of its own quiet solar system, somewhere in the dark. The universe is made up of about 68% dark energy, 27% dark matter, and only 5% of the ordinary matter that makes up everything we can see, touch, and measure. Every star, every planet, every ocean, every mountain, every living thing. All of it together accounts for just 5% of what exists. The rest is invisible, undetectable by any instrument we currently have, and yet it shapes the entire structure and fate of the cosmos. We live in a universe where almost everything around us is something we do not yet understand. That is not a failure of science. It is an invitation. Galaxies are not scattered randomly across space, like seeds thrown by a careless hand. They are arranged along enormous invisible structures, long filaments, flat sheets, and massive walls of matter that together form what scientists call the cosmic web. These structures stretch across hundreds of millions of light years, forming the largest known patterns in the entire universe. Where the filaments intersect, enormous clusters of thousands of galaxies gather together, and between them, vast empty regions called voids stretch on for hundreds of millions of light years, nearly silent and nearly empty. The very first stars in the universe were unlike any stars that exist today. They formed from clouds of pure hydrogen and helium, the only elements that existed after the Big Bang, and they had no heavier elements at all. This made them burn extraordinarily hot and bright, living fast and dying young in enormous explosions. Those explosions created the first heavy elements, carbon, oxygen, iron, and scattered them across the universe for the next generation of stars to use. Everything we are made of was forged in those first ancient, unnamed stars that no human eye ever saw. The Milky Way is surrounded by over 150 ancient globular clusters, tight, spherical collections of hundreds of thousands of stars packed closely together. These clusters are among the oldest objects in the galaxy, many of them nearly as old as the universe itself. They orbit the Milky Way in long, looping paths through the halo, like slow satellites of an enormous planet. Looking into a globular cluster through a telescope is like looking at a swarm of ancient lights, all burning together in a tight, quiet sphere. They are some of the most beautiful objects in the known universe. The Large and Small Magellanic Clouds are two small, irregular galaxies that travel alongside the Milky Way through space. They are visible from Earth's southern hemisphere as soft, glowing patches of light in the night sky, easily mistaken for detached pieces of the Milky Way. They are being slowly pulled and stretched by our galaxy's gravity, leaving a long trail of gas called the Magellanic Stream behind them. Eventually, in billions of years, they will be absorbed entirely into the Milky Way. For now, they are our closest galactic neighbors, companions on a journey through space neither they nor we chose. Cosmic rays are invisible, high-energy particles that travel across the galaxy and rain down on Earth constantly, day and night, without pause. They come from supernova explosions, from the neighborhoods of black holes, and from other violent events scattered across the Milky Way. Most of them are harmlessly deflected by Earth's magnetic field and atmosphere, but a few of the most energetic ones pass straight through everything, through the sky, through buildings, through you, right now, as you rest. They are silent messengers from the most extreme corners of the galaxy, passing through without a sound. The Andromeda Galaxy is the most distant object visible to the naked human eye, sitting about 2.5 million light-years away from Earth. On a dark, clear night, it appears as a faint, soft smudge of light near the constellation Andromeda. The light you see when you look at it tonight left that galaxy 2.5 million years ago, before our species even existed on this planet. You are not just seeing another galaxy. You are seeing 2.5 million years into the past with your own eyes. No telescope required. It is one of the most quietly extraordinary things any human being can do on a clear night. Supernovas, the enormous explosions that mark the death of massive stars, are so unimaginably bright that they can outshine every other star in their host galaxy, combined for days or even weeks. A single exploding star, for a brief moment, produces more energy than the Sun will release across its entire 10 billion-year lifetime. These explosions are also the universe's great factories, creating and scattering heavy elements across space. Iron, gold, silver, uranium. Many of the elements found on Earth arrived here because ancient stars exploded long before our Sun was born. The gold in the world was made in dying stars. Most stars in the universe are not like our Sun. The most common type of star is the red dwarf, a small, cool, dim star that burns its fuel so slowly and carefully that it can shine for trillions of years without running out. While our sun has a lifetime of about 10 billion years, a red dwarf might burn steadily for 10 trillion years or more, long after most other stars in the universe have gone dark. The universe is still young enough that no red dwarf star has ever died of old age. They are the quiet, patient, long-lived elders of the stellar world. The Milky Way's disk is not perfectly flat. It is gently warped at its edges, bent like the brim of a wide hat that has been softly pushed from below. Scientists believe this warp was caused by the gravitational pull of the Magellanic Clouds tugging on the outer parts of the galaxy over billions of years. It is a subtle but real distortion that stretches across tens of thousands of light years. The galaxy we live in is slightly bent, quietly lopsided, shaped by the same invisible forces of gravity that shape everything else in the cosmos. Nothing in the universe is perfectly still or perfectly straight. The universe likely contains more planets than stars. Most stars, it turns out, have at least one planet orbiting around them, and many have entire families of planets, moons, and smaller bodies. With hundreds of billions of stars in the Milky Way alone, and trillions of galaxies beyond it, the number of worlds in the universe is almost beyond any number we have words for. Some of those planets orbit in the right zone, not too hot, not too cold, where liquid water might exist on the surface. Out there, somewhere in the quiet dark, there may be other worlds with oceans, with weather, with nights just like this one. Some galaxies appear to spin faster than the known laws of physics should allow. If you calculate how much visible matter a galaxy contains, all its stars, gas, and dust, and then measure how fast it is actually spinning, the numbers do not match. The outer parts of most galaxies spin far too quickly and should, by all rights, fly apart into space. The only explanation that fits is that something invisible, something with mass and gravity but no light, is holding them together from the outside. That something is dark matter, and its quiet presence is the only reason most galaxies exist in the shape they do. Wrapped around the Milky Way are long, thin rivers of stars called stellar streams, the ghostly remains of smaller galaxies and star clusters that our galaxy pulled apart long ago. Gravity stretched those ancient structures into ribbons that now drift slowly around the Milky Way like the threads of a web. Scientists have found dozens of these streams by mapping the positions and movements of millions of individual stars. Each one is a quiet fossil, a memory of a smaller galaxy that no longer exists, absorbed into something larger, its stars now wandering far from where they were born. Stars are being born somewhere in the Milky Way right now, tonight, as you rest. Dense clouds of cold gas in the spiral arms of the galaxy are slowly collapsing under their own weight, their centers growing hotter and denser with every passing year. In a few million years, a blink of cosmic time, those centers will ignite and new stars will shine for the first time. They will be surrounded by disks of swirling material that will eventually become planets. The galaxy is not finished. It is still building, still creating, still quietly at work in the dark. If you could somehow travel to the far side of the Milky Way and look up at the night sky, you would not recognize it at all. The constellations we know, Orion, the Big Dipper, Scorpius, are patterns formed by nearby stars as seen from our specific location in the galaxy. From a different vantage point, those same stars would appear in completely different positions, and entirely new patterns would fill the sky. The constellations are not real shapes in space. They are pictures drawn by perspective, unique to the exact spot in the universe where we happen to live. Space between the stars is not truly empty. It is filled with an incredibly thin mixture of gas, dust, charged particles, and magnetic fields called the interstellar medium. This material is so sparse that it would be considered a near-perfect vacuum by any laboratory standard on Earth, and yet it is there, drifting quietly between the stars in vast, cold clouds. It is the raw material from which new stars and planets will eventually be made. The emptiness between things is not wasted space. It is a slow, patient reservoir waiting for gravity to begin its work once more. Red dwarf stars are the most common type of star in the Milky Way, making up about 70% of all stars in the galaxy. They are small, cool, and burn so dimly that not a single one of them is visible to the naked eye from Earth, despite being our closest stellar neighbors. Because they burn their fuel so slowly and carefully, they can live for tens of trillions of years, far longer than the current age of the universe. Any planets orbiting them would have an extraordinary amount of time for something remarkable to develop. The universe may be full of very old, very patient worlds circling very quiet stars. The Milky Way has two distinct layers in its disk, a thin disk and a thick disk. The thin disk contains younger stars, including our Sun, that follow relatively circular, orderly orbits close to the galactic plane. The thick disk sits above and below it and contains older stars that move in wider, more irregular orbits, relics of the galaxy's more chaotic early years. The two layers formed at different times in the galaxy's history and have different compositions, telling scientists a story about how the Milky Way grew and settled over billions of years. Our galaxy has layers, like the rings of an ancient tree, each one a chapter in a very long story. Every galaxy in the universe has its own history, its own timeline of formation, growth, collision, and change. Some galaxies are ancient and quiet, no longer forming new stars, their light slowly fading over billions of years. Others are young and turbulent, blazing with the light of millions of newborn stars. Some are in the middle of colliding with their neighbors, their shapes twisted and distorted by gravity into strange and beautiful forms. No two galaxies in the universe are exactly alike, just as no two lives lived on this small planet have ever been exactly the same. The cosmos is endlessly, quietly varied. Even the smallest, most fundamental pieces of matter, atoms, are mostly empty space. If you could expand a single atom to the size of a football stadium, its nucleus would be no larger than a marble sitting at the center of the field, and its electrons would be tiny specks orbiting somewhere near the outer seats. Everything you have ever touched, every object that has ever felt solid to your hand, is almost entirely empty space held together by invisible forces. The chair beneath you, the bed beneath you, the ground beneath this world. All of it is mostly nothing, shaped by forces we can measure but never truly hold.